Hello everyone. Today I'm going to give a presentation on our topic crop yield production. This presentation was guided by Shivaranjani ma'am and our PPL coordinators are Shivaranjani ma'am and Mukta. And my team is Rashis out myself, Jayadar Ramar, Nichinas and Rahul are getting introduction. Agriculture is crucial for food security. Crop yield prediction is difficult due to weather changes, soil diversity, and traditional estimation methods. Machine learning can solve this by using historical and real-time data to make accurate predictions, helping optimize resources. A problem statement. The current issues are farmers rely on guesswork and intuition. Climate unpredictability makes it worse. Observations. Developing an ML-based system to predict crop yield using input like weather, properties, and crop details. Data sources and features. The types of data. Here we are using the data like weather, which includes temperature, rainfall, and humidity. Soil, which includes the pH, nitrogen, phosphorus, and the potassium level. Crop, which we have the data such as past yield and growth stage. Sources are Kaggle, government databases, and simulator sensor data. Now let's move to data preprocessing. Here there are basically three parts. First one is data cleaning, second one data transformation, and finally we have feature selection. First one in data cleaning we have we remove null values and outlier, which means missing data and extreme or unrealistic values were filtered out and to improve model accuracy. Then data transformation. In this, we have two parts, that is normalization and encoding categorical values. Normalization means scaling down numerical values like rainfall or NPK levels so they contribute equally during model training. And encoding categorical values here means converting textual data such as crop type into numerical format using techniques like one-hot encoding. And last we come to feature selection. Here we identify and keep only the most relevant variables to avoid overfitting and reduce training time. Tools used. Here the tools used are Python and Pandas, especially for data handling, and skitlearn for preprocessing functions. Next, we have model implementation, in which the languages and library used are Python, uh, with packages such as NumPy, Pandas, and skitlearn for ML tasks. The ML models explored here as linear learning and neural networks. Linear regression is a simple algorithm assuming a linear relationship between the features and the yield, whereas the neural network is more advanced and is useful if complex non-linear patterns are present. Process. Here we split the data into 80-20. That is, 80% of the data was used for training and 20% to test its performance. Then cross-validation. The evaluated model is the evaluation done using the different data sets which are unseen and hyperparameter tuning. The optimized model setting using methods like grid search. Next, here is a code implementation. This is a code snippet which shows us the pre-processing model training and evaluation. Next, we have data sets here. Here, as you can see, there are temperature, rainfall, humidity, soil pH, NPK levels, and pass yield and the yield. Next, we have front-end implementation. Here, we have the web interface of our project. It also has the HTML code, which is displayed. And next, we have the model training. In this, we train the model on cleanest and the process data sets. It is used to test the data to validate performance. Next techniques, we have the R square score, which indicates how well the model explains variability in yield. Closer to 1 means better performance, and farther than 1 means poor performance. Then RMSC for prediction error. Here, RMSC stands for root mean square error, uh, which tells us how much the error is. Then, then is the grid search for tuning. It tested different combinations of model parameters to find the most effective setup. Then we have model performance. Here, as you can see, we have taken the R-square score as 78%, which is a good fit. That means it is 78% accurate, and the RMC score is 5.4, which means it has low error ratio, low error rate. Best performing model here is linear regression because it is simple and it is consistent. Result interpretation. Here we have the key observation like rainfall and pH are the most influential factors in predicting yield. Insights. Here we can say that soil properties and timely rainfall have major impact for the yield. Then data-driven approach can guide farmers' decision and help them save the resources. Then we have the challenges and limitations. First, we have the challenge, which is incomplete data sets, which will affect our model accuracy. The solution is we can impute and data cleaning. Secondly, we have limited real-time inputs, which makes our model less practical. We have thought to integrate our model with IoT in future. Overfitting in complex models, which gives low generalization to our model, which we have thought to apply cross-validation in future. Then tech adoption by farmer is low usability. We have planned to launch a mobile application which the farmers can use easily and help team learning and reflection. Linear regression model showed consistent result. Good teamwork and effective task distribution made it more useful. Challenges encountered. The limited time for implementing a live model. Difficulty handling incomplete data sets. And key learning is that pre-processing is a very important step before any model training. And the model chosen can greatly affect results and should be guided by the problem and the data. Future scope. Here, the next step we have basically the four things. First one is the IoT sensors for real-time soil and weather data collection. The satellite data to enhance the geographical accuracy, AutoML, to automate ML selection and tuning in the mobile app, which allows the farmer to input data and grid prediction on the go. And the vision is to build a smart, real-time, farmer-friendly crop advisory system. Conclusion. First, I conclude by saying that ML model can revolutionize agriculture by delivering timely, accurate prediction. With proper data, farmers can make better decisions, saving resources and increasing yield. Hereby, it impacts in sustainable and efficient agriculture, highlights the value of data-driven innovation in traditional sectors. Thank you.